The next one is a three-phase three-wire star connected unbalanced load. So normally for the three-phase is a balanced situation. The phase voltage are the same, and the neutral wire carry the zero current. If you use a three-phase unbalanced and the four-wire supply here, so this is a three-phase system. Normally we connect like this. So this is a neutral wire. So this neutral wire usually carries to the phase current. So this one is a IA. Okay, this is a IB. This is IC. So neutral current is a minus, IA plus, IB plus IC. IA beta plus IB beta plus IC beta. So this is the IN current. So normally the three-phase is going. So long as the neutral wire is connected, all phase voltage are the same. So phase voltage, so this is the VAN. So VAN, VBN, and the VCN. Their magnitude are the same. So VAN is a E, for example, this one is E, this one is E. So their phase voltage are the same. So long as the three-phase neutral wire exists, all the phase voltage are the same. But sometimes neutral wire can be broken down. The neutral wire broken down is a danger. When the three-phase is unbalanced, neutral wire broken down, what will happen is that this is an original start point. So this is VAN, VBN, and the VCN. This is a start point and point. So this is for the with neutral wire. But when the neutral wire broken down means that this is a three-phase system. So this neutral wire is broken down. Neutral wire broken down means when the neutral wire broken down, the phase beta is no longer this shape. Then neutral wire point shift to somewhere. So this is the original point. A, this is B phase, and this is C phase. And then the neutral wire broken down means this start point change to the other place. So this is O point. So this becomes the PNO. PNO hasn't between the original start point and the new start point. So in this case, the voltage will be the change. So this is the VAO, VVO, and the VCO. Voltage will be the same. Voltage will be changing. So this voltage VNO. This VNO, because the VNO original start point is changed to the new point, so that all phase voltage will be changing. So phase voltage changing means that some phase called the over voltage. So that all equipment connected to this over voltage phase can be damaged. So that we have to calculate that this voltage by two ways. First method is method one is that you only calculate in the for calculation, we have to change the star to delta. And then we have to calculate the delta solution. Calculate the delta circuit, you have to calculate the phase current and the line current. Change the star to delta, calculate phase current and line current. And you have to also use that method 2. Method 2 is that we have to find the VNO. We have to find the VNO. So VNO we find by the formula. So this is the formula to find the VNO. So this VNO you can calculate by this formula. VNO is equal to VAN. So this is, we can also kind of say the VON. So this is VON, VN into YA, plus VBN into YB, plus VCN into YC, divided by YA plus YB plus YC. So YA is being there, YYZE. YB is YYZE. YC is 1 by ZC. So firstly we have to calculate VN ON, find the formula. The formula is VN YA plus VBN YG plus VCN YC divided by YA plus YG plus YC. Then you calculate the VON. Then you have to calculate the VAO. VAO is VAN minus VON. Then you can calculate that IA. IA is equal to VAO into YA. And similarly, VBO you can calculate. So this is VBN minus VON. Then you can calculate IB. So VBO into YB. And similarly, you can also calculate the VCO. VCO is a VCN minus VNO. Then you can calculate IC. IC is a VCO into YC. So this is method 2. Method 1, we have to change the data to star, and then we have to utilize the stars and unbalanced load. The data unbalanced loads, and then you have to calculate the line current and phase current. Method 2 is you have to find the original star by voltage and new star by voltage VON, and then you use this formula, and after that you can find the new voltage VAO, VBO, VCO you can find, and IA you utilize VAO multiply YA, IB is a VBO multiply YB, IC is a VCO multiply YC. So this is method 2. And method 3 is that you have to utilize the Kasha law. So in this case, I will show you that I will utilize the method 2. So there are 3 ways to solve that 3 phase stars and unbalanced load. Method 1 is that we change the star to delta, you sort in the data. Method 2 is we calculate the VON, then we use the formula to calculate. Method 3 is that you have to use the Kasha law.